Hello and welcome to video 13 for Math 123. This is our second video on the topic of geometry. This video actually we're going to be talking about triangles. I'm going to be honest with you, this is one of my favorite topics. One of the other classes that I teach frequently is trigonometry, and it uses a lot based on triangles. So there's so much that we can do with the triangle figure, and especially if we get a right triangle, then we get all kinds of good features there. So I'll try to control my excitement, but as I said, this is one of my more favorite topics, is triangles. So first of all, let's look at some classifications. We have what's called an acute triangle. So, thinking back to the last video, when we were talking about angles, what was an acute angle? That was what? It was when an angle was less than 90 degrees. Acute triangle is when all three angles are less than 90 degrees. We have an obtuse triangle. So obtuse meant what? The angle was bigger than 90 degrees. Well, with an acute triangle, all of the angles were less than 90. Obtuse, we can only have one angle bigger than 90. And in a triangle, the total sum of all the angles is 180 degrees. So I couldn't have three angles bigger than 90 degrees and still be less than 180. So be careful here. Acute triangle, all the angles are less than 90. Obtuse, one angle is greater than 90. So if I look at examples in acute triangle, might be something like this. There's nothing bigger than 90 degrees. Obtuse triangle, I have to have one angle bigger than 90, the other two are smaller. And then the third type is what's called a right triangle. As the name is implied, there's one right angle, one 90-degree angle. And so we notate this with creating a little box. So if we see a triangle with that corner that looks like a square, that's our notation that that's a right angle, that's a 90-degree angle. It doesn't even have to tell us that. The picture alone would tell us that. So that's when we are talking about the angles of a triangle. If we're talking about the features regarding the sides, I can have the following. I can have a scalene triangle, and this is when no sides are equal. So maybe I have a little side here, maybe a little longer side there, and then a really long line going there. None of the three sides are equal to each other. If I have what's called an isosceles triangle, this is two sides are the same length. So I might have something that looks like a dunce cap or something like that. So the two vertical pieces are the same length, the bottom side is different. And lastly, what's called an equilateral triangle. So as the name implies, we have what? Equal. It's like equal, meaning all three sides are the same. So an equilateral triangle, all three sides are the same, which also then means that all three angles are the same. And as I mentioned earlier, a triangle has 180 degrees. So if all all three angles are the same and it has to total up to 80, then it means what? All three angles of an equilateral triangle would be 60 degrees. And again, this is important because sometimes you might just be given a word problem that says, in an equilateral triangle, blah, 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 whatever. And you need to know one of the angles, and they don't tell you. Well, they don't have to tell you because an equilateral triangle has to have all three angles are 60 degrees each. All right, so as I told, that has to do with the sides. We talked about the angles. As I mentioned at the start of the video, we have this classification of triangles called right triangles. And these are like a dream come true for people in a lot of different fields. Mathematics, engineering, construction, things like that. Because if we have a right triangle, we have a lot of properties that go along with it. Whoops, right triangles. All right, so in a right triangle, if you remember the picture I drew a little bit earlier, we have a right angle. The side of the triangle that's opposite the right angle is what's called the hypotenuse. And this is always opposite the right angle. The other sides of the triangle, and if this is, whoops, I spelled this wrong, hypotenuse, P-O-T, hypotenuse. So the other sides are just called leg 1 and leg 2. Now, the next thing I'm about to show you guys is probably one of the most common known math formulas in the world. If you go see anybody out on the street and ask them, hey, do you know the Pythagorean theorem? Most people will know this. And it's the following. So if you ask people, oh, what's the Pythagorean theorem? They're probably going to tell you what? A squared plus b squared equals c squared. And that's the formula, except we have to be careful about a few things. So first of all, in a right triangle, so if it's not a right triangle, if it's just any triangle at all, a squared plus b squared does not equal c squared. Only in a right triangle. So in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So, if I said leg 1 has length equal to A, and leg 2 has a length equal to B, and if the hypotenuse has a length equal to C, then yes, as everyone would tell you, A squared plus B squared is equal to C squared. So we have a special class of right triangles from Pythagoras himself. Because of this formula, they're called Pythagorean triples. So what this means is, in general, like we can't just say, oh, the triangle can be 1, 2, 3. Because 1 squared plus 2 squared is not equal to 3 squared. But there are some triangles that is true, where the numbers work out nicely. The first one is 3, 4, 5. So if I have a triangle a right triangle, one side is equal to 4, the other leg is equal to 5, the hypotenuse, sorry, one leg is 3, the other leg is 4, the hypotenuse then has to be 5. That's a 3, 4, 5 triangle. We also have 5, 12, 13. So if one leg is 5, the other leg is 12, the hypotenuse is 13. 8, 15, 17, and 7, 24, 25. So these are a nice set of 4 that this is true. Now, any multiples of these are also true. So if I take 3, 4, 5, and I double all the numbers, 6, 8, 10, this is also a Pythagorean triple. So maybe on the test it'll say, I have a triangle with one side is equal to 6, and the other side, and the hypotenuse is equal to 10, find the missing leg. Well, you could do Pythagorean theorem, so 6 squared plus b squared equals 10 squared. Take the squares, subtract the 36, take the square root. You could do all that. But if you notice right away that, oh wait, 6 and 10, that's double of 3 and 5, so I just have to double the 4, so the other leg is 8. And it'll save you a little bit of time there. Alright, so those are Pythagorean triples. And the last thing I want to talk about here with triangles are what we call special triangles. So when we had the right triangle, we had the Pythagorean theorem, a squared plus b squared is c squared. We have two types of special triangles. We have a 30, 60, 90. So if I have a right triangle, so this angle is 90, let's say this little angle is 30, and so we know that the total angles of a triangle is 180, so therefore 180 minus 90 minus 30 means this angle has to be 60 degrees. When I have this situation, so this leg is my short leg, so let's call this A. A feature of this special triangle of a 30, 60, 90 is that the hypotenuse is twice as long as the short leg. So that would be 2A. And the long leg is the short leg times square root of 3. So again, you can always do this mathematically with the Pythagorean theorem. So if it told you you have a 30, 60, 90 triangle, and one side is, so let's do an example here. If it told you one side is, the short leg is 3, and the hypotenuse is 6, find the length of the long side. If you don't remember this, or you're not real comfortable with special triangles, use Pythagorean theorem. It's not going to take you that much longer, and you'll get the answer 100% of the time as long as you do the math right. But if we know that this is a 30, 60, 90 triangle, I know the long leg is just take the short leg and multiply it by square root of 3, so without doing any calculations, I can get that answer. That's how it's going to work out. That's a feature of the 30, 60, 90 triangle. The other special triangle is a 45, 45, 90. So this one is an isosceles triangle. So two sides and two angles are the same. In this case, they're both 45. The feature with this one is that the legs are the same length, so we'll call it A and A. And the hypotenuse is always A times the square root of 2. So not double like in the 30, 60, 90, but A times the square root of 2. So if I have a 45-degree triangle, 45-degree right triangle, and this side is, let's say, 5, that means the other side has to be 5. It's an isosceles, you have to have two legs the same. The hypotenuse is 5 times the square root of 2. And again, if you don't want to worry about, okay, when is it square root of 2, when is it square root of 3, does this qualify, is it the short leg, is it the long leg, etc., just use Pythagorean theorem. That will be your safest bet all the time, and that would be my suggestion to you guys, instead of trying to worry about memorizing these special cases. So that wraps up that one. What do we have there? 15 minutes. Okay, good. So that's our video on triangles. Come on back and we'll start talking about some other polygons, some other figures that we're going to encounter in geometry.